Good morning, fellow programmers! Thanks for joining me. I am T-Pain, and welcome to Let's Learn Python. Feel free to use the skip ahead feature on the right hand side to jump to any specific sections or examples. Today we'll be using Python 2.7.6 and Python 3.3.3. You can download those from python.org/getit. Today we'll be focusing on PyQt and OpenGL. This will build heavily on past lessons, so feel free to go back and watch them again if anything is unclear. Alright, OpenGL. What is OpenGL? Well, OpenGL is a raw graphical programming language that works across most all platforms rendering 2D and 3D graphics. DirectX is the other big graphic language out there, though it tends to be more Windows and PC focused. OpenGL can be difficult to program in by itself, which is why there are utilities out there like GLU and GLUT to help ease programming for OpenGL. And you don't want to even know about half OpenGL and closed-GL, because I just made those up. Alright, to install this, you go to pypy.python.org/pypy/pyOpenGL. Let's go ahead and visit that page so we can see it for ourselves. And if you open it up, this is what you should get. And the download modules are right there. There's the installer for Windows. If you're using Mac or Linux, you should be able to find the installation instructions within theirs. So how do we use it? When you install OpenGL and PyQt, there's a whole bunch of files that are actually already created for you. Some example files for just about anything you can imagine. To locate these, open up your Explorer, go down to your C drive, and then from here you go to Python 2.7 or 3.3 if you're using 3.3, and then you go under lib, and then under here you go to site packages, and then PyQt4, and then examples, demos, qtdemo, and then scroll down and you'll find qtdemo.pyw. Double click this, a little arrow may pop up, go ahead and ignore this, and then you'll be prompted with this nice window. And what this is basically to launch off any and all the examples that are provided with Python and PyQt. So if you want to do an example where you're networking, you can inspect these. If you want to jump into an example with, let's say, painting, you can check out those. I encourage you to actually play it out with most of these. The ones that we're going to be focusing on are in the OpenGL module. And then we're going to click on Hello GL. Once you click on it, click Launch on the right-hand side, bottom, and here we go. So first off, this is the OpenGL window that's with the faint purple on the left-hand side, and then notice that it'll actually scale with the widget, which is awesome. And then there's these sliders that control the X, Y, Z rotations of the objects inside the little Qt. So when we could slide these around and rotate him around all the different axes, or we can actually click within the window itself and navigate around. You can right click or left click to control the different axes you want to rotate on. And notice as you do so, the sliders on the right hand side update. Fantastic! Let's go ahead and close that down and examine the code for it. So open your favorite text editor of choice. Mine is Sublime Text. I'm going to go ahead and line that on the left side. And then we can actually open up the code itself for that example. Now where you go to is under Examples, and then you scroll down to whatever folder it was that you were checking out. For us it was OpenGL, and then we have the Hello GL right there. Click and drag, boom, here we go. So the first bit of code is a whole bunch of just legal jargons. Go ahead and skip past that and scroll down. PyQt OpenGL, that's one of the modules that is imported. This is what's going to allow us to do some of the OpenGL stuff. The other stuff comes from the GL module that's on its own. Notice here that we import it, and if we fail to import it, then we're just going to go ahead and exit out of the program. Okay, so right here we have the window class, which is the main window itself. And here we have the creation of the GL widget, some sliders. We connect those sliders to different actions. We have the sliders placed in the layout. Here we set the default parameters of the sliders, and then finally we title the window. Okay, scrolling down a little further, we have the actual setup for these sliders because they're very specific for what we want. Okay, scrolling down even further, now we're going to get in the OpenGL widget itself. So we inherit from the class qgl widget right here, and then right below that we have a bunch of variables that are actually going to be signals. These signals are what's going to bind the sliders to the OpenGL whenever we click around it within the window. So this is what's going to allow us to interactively change the sliders and everything all at once. Below that, we have the constructor function init. We set up the class that it inherits from. We set up a few variables. And then we have this interesting variable called last pose. Last pose is basically to store the last position that the mouse was at before it updated. And so it's stored in the special format. I think it's like a tuple. It's a Q point. And then here we set up a whole bunch of colors. We set up green and then we set up purple. Okay. After that, scrolling down, we're creating an overriding function called minimizing size hint. And this is basically what sets the absolute minimum that the window will shrink down to. So if we go ahead and run that application again, go ahead and launch it. When we try to shrink this window down as small as it can get, this will be 50/50. So this is 50 pixels by 50 pixels is the smallest that it will get. And that's caused by this size minimum hint. So then we have this size hint, and that's basically to set up the default parameters, although they're slightly dictated by the size of the window itself. So this may be overridden or ignored. Next, below that, we have three functions for setting the rotation of the object. Here we retrieve the angle of the current object based off of the mouse position trying to rotate it. Then we check to see if the position has changed at all for that particular angle. And then finally we override, admit that there has been a change so that the sliders will update. And then finally we call this function called updateGL. What updateGL is it's basically a call to say, hey, go ahead and update the frame. So we'll redraw the frame as it really should be. It's basically just to redraw the frame. Okay, and then we have the Y and Z rotation set here. Then we have initialize GL. Now when you're programming in C and C++ in OpenGL, then you're going to have an init function, typically. And this init function is basically to set up parameters. This is the exact same thing. So let's come through this line by line and see what GL is doing. So here we say GL clear color, and this is basically to set the background color every time we clear the frame. So, and then we set it here to purple dark. After that, we have the creation of the object itself. This function is defined down below here, and this is where our object is actually going to be created. After that, we have GL shade model, and this is basically setting up how the lighting conditions are going to be for everything in the scene. Now we have GL flat. Now what this means is basically everything's going to be flat shaded and not affected by lights. In fact, we're actually going to have everything just be solid colors. So it'll be a kind of toon shading, if you guys are familiar with that. The other option that we could have is smooth. But if we were to put that there, then we would need to place lights within the scene. After that, we have GL enable, and this is basically saying, hey, let's enable certain features of OpenGL to be activated. And here we have GL underscore depth test, and this is so polygons that are distant and polygons that are far are displayed correctly, so that if they're overlapping at all, then they won't actually overlap, because otherwise what will happen is it will always draw like the first polygon first, even if it's further away, and so it'll look really weird. And yeah. Next we have GL underscore cull underscore face, and this is for culling back faces. So basically you check the normal on a particular face, and if it's facing towards the camera, then we render it. If it is facing away from the camera, it is ignored. So that is why if we were to rotate the camera around this object, if we only had a plane, it will be invisible. And we'll be going over that in just a minute when we actually adjust the code ourselves. So let's scroll down a little further. So now we call this function called GL clear. Now GL clear is basically to clear the depth buffer and to clear the color buffer. And if you want to read up on any of the documentation for these particular guys, it's as simple as a Google search, or I'll point to the documentation of real in-depth literature later on. After those buffers are cleared, then we call this load identity, and this basically says clean out the entire scene, whatever we have rendered, and make a nice clean frame. And so what we're going to be displaying is just this clear color right here. Next, we call this translated function, and we're pushing it out in negative z-axis. So that's to push the object out away from the camera. Otherwise, they would be positioned at the exact same spot. This next function is GL rotated, and this is basically to set up the rotation along one of the axes. Now, this setup is for the amount that you want to rotate, and then which axes you want to rotate on. So this is X, Y, or Z. It is possible to actually punch in one for each of these so you rotate along all three at the same time, although that's very clunky, and yeah. After that, we have the function to actually create the object. So this is GL call list, and a call list is basically storing an object in memory. And here we're actually reading it back so it can be created. Something odd about OpenGL is that when it's rotating and translating guys and scaling them, it's actually going to do it in reverse order. So first our object is created, and then we rotate along the Z, Y, and X rotations, and then at the end we translate it out away from the camera. So that's why when we jump back to our application, let's go ahead and scale this back up. As I rotate it, it looks like it's rotating about the center of the object, when in actuality, every single frame, it's going to be positioned here at 0, 0. It's going to be rotated that way, and then it's going to be pushed out as the final step. And so that's happening every single frame. Very cool. Okay, so let's scroll down a little further, and we'll see the resize GL function. This guy is so when the widget is resized, when the whole window actually is resized, the widget actually scales to fit the space allotted to it. And it says, hey, if we've ever hit a moment where we're at too small or less than 0, then we're going to go ahead and just kill it. Otherwise, we're going to go ahead and try to set the viewport size, set the matrix mode. This matrix mode thing, this is basically, we have two different matrix modes. We have projection, and then we have model view. Projection is to set up the camera. Model view is to set up the objects in the scene, and lights, and that sort of thing. So after we set up the camera into projection mode, we're going to load identity to clear out the frame, clear out the buffer, clear out everything, and then we position the camera, and that's GL ortho. And ortho is to create a camera that's isometric versus perspective, so everything looks flat. Then GL matrix mode switches it back so that we can switch to drawing objects. Okay, scrolling down a little further. Now we have define mouse press event, and then we basically set the position for last position to whatever that current position is. This is so that whenever we click the mouse, whether it's the left button or right button or middle button, it's going to actually record the last position. Now, after that comes mouse move event, and this is basically the detection of when the mouse is moved. And so here we check for how much it is moved since the last update. And so then after that, we've determined how far the mouse has moved, and then we're just going to go ahead and set the rotations based on if the right button or the left button were actually hit. And then finally, we store the new position that the mouse is at. So every time we click and move around, it'll update. Cool. Scroll down a little bit further. Next we have make object, and this is to actually create the objects that are going to be displayed in the scene. So this is the giant Qt. I've actually added in a line right here, and I'll explain what that is in a bit. So first thing is that we create this gen list, this general list of stuff. And we're saying that, hey, it's going to be a size of 1, and here we're actually going to bind this gen list to a new list. So everything listed after this is going to be stored within that list, and we're going to be in a compiling mode. Finally, we have this function called glBegin, GL quads. So what's going on here? glBegin is basically like, hey, I'm going to start drawing geometry. Could be lines, could be triangles, could be quads, could be any number of things. And then you're going to define, hey, what are we actually going to be creating? GL quads is a way to create quads for every 4 vertices. You're designating the points on which you're creating a polygon. We could easily change this to something like lines. There's a bunch of different things that we can actually plug in here. Lines is one of them. Watch what happens if we actually plug in lines. Let's go ahead and save that and then launch it. And everything will be displayed in sort of a wireframe now. Very, very cool stuff. There's no lines actually connected these two. They're actually just like, looks like 2 circles. So very cool stuff. We can also change this to a quad strip. We can change these triangles. But let's go ahead and just leave them as quads. All uppercase, save it, and now we're back to defaults. And then after this is a whole bunch of code that somebody else created to create the actual Qt. So there's not much to note here other than we're calling the functions that somebody else created right here, like quad. this is actually a self-made function, so if we scroll down a little bit, we'll actually see the quad function, and this is basically like this group of 4 calls is to create an actual quad. Here they're actually like basically creating the same quads over and over again because they want to create them slightly spaced apart, and then here you're actually designating the color. It's interesting to note that you have to designate the color for the object you're drawing whenever you change objects. Okay, so yeah, that's what quad does, and then you can look at extrude. Extrude is going to be making the in-between quads. Yeah. Okay, scrolling back up to finish up this bit of code. So that's all creation stuff. Right here after this is the GLEnd function. GLEnd is basically to encompass everything after GLBegin. So wherever you have a begin, you have to have an end in order for OpenGL to understand, like, okay, I'm going to stop here. After that, you're going to go GLEnd list so that we know we're not creating any more objects. And the list is completed. And so everything is going to be then packaged up and stored in that variable genList that we created up above. And then we just return that genList. So everything's stored in memory. Beautiful. Finally, after this, we have the normalizing angle. And then we have the generic code that we've seen over and over again. And that's the run the application, create the window, show the window, and then run everything all at once. And close out when we're done. Cool. I want to actually like begin tweaking a little bit of this code. So what we're going to do is we're going to actually comment out all the code for the creation of the Qt. And we're actually just going to type something real quick in. So go ahead and select everything here under the quads and go ahead and comment that out by pressing Control question mark on Sublime Text Edit if you're using that. And then I'm going to go ahead and uncomment this line out. And what this is self.quad and then open parentheses, and then this basically jumps back and forth between x and y coordinates. So x, y is 0, 0, x, y is 0, 1, and then x, y is 1, 1, and then 1, 0, and that'll finish out the quad. So let's go ahead and save that and launch the application. And now look at what we've created. We've actually changed that to a square. So we now have a square where we once had the Qt. And as we tumble around it, you'll see that there's one face, and as we turn around it slowly, the other face slowly appears. Now this is what I was talking about with the culling. If the polygon is pointing away from the camera, it's not rendered at all, and it looks invisible. So yeah, that's why there's only ever one polygon on scene as we tumble around. And because the quad function creates 2 quads instead of 1, that's why we have 2 of them. Okay? And so yeah, that's just about it. So as I said, you have access to all of these applications through the examples. I encourage you to go through and play with them all. Try changing colors of stuff. Try like seeing if you can combine different ideas together in the same example. Really have fun experimenting, because you're going to learn a hell of a lot more than anything else. For further documentation on OpenGL to see what exactly you can do, is you can go to Wikipedia and just Google search OpenGL, and you'll be able to see. And this is the logo of OpenGL, and on the wiki page you can just scroll down and you'll be able to see documentation right here. And the red book is actually the basic Bible of OpenGL. Everything that you need to know about it is contained within here. Below that there's like some very specific stuff for like programming shaders and stuff, and giving stuff materials. So in video games, when you see like all sorts of moving textures and like clever combinations of textures and stuff, that's what a shader is. A shader is basically allows you to combine different textures, add different colors on, give you complete control over a material of a given object in a game or cinematic. And then there's also other books for covering very specific topics if you want to do Windows system or whatever it is. Alright, so why use it? In programming in OpenGL, you're going to get your skills a hell of a lot sharper than if you didn't, because programmers who know OpenGL are freaking, they make bank. Let's just put it that way. They make bank. An incredible programming language to know, and if you can do it, you can work wonders. You can do absolutely amazing stuff. It takes a little time and a lot of practice, but you can do some great stuff. So we've officially reached the limit of my knowledge. As of right now, I have taught you just about everything I know with Python. The tutorials will be coming at you less and less frequently. It's only stuff that I am comfortable teaching, which like I started delving into databases, didn't quite feel comfortable, so I just ditched the idea. Here is a sneak peek of some stuff that I'm working on. And developer of the anti-gravity theorem. Nobody cares. Shh. shit. It's raining. Well, so thanks you so much for watching. Great job keeping up. Definitely take a few minutes to investigate these final challenges. As you are a brilliant programmer, I'm sure it'll be a piece of cake for you. I will not be posting the solutions because I want you to develop your own skills and solutions. There is no correct answer. Please leave me a comment below if this helped you at all. And please do me a huge favor and subscribe to my channel. It would really mean a lot to me. Also hit the like button to show some love. Thank you so much for your support and keep the dream alive.